Hello viewers, this is the video lecture for the topic Ambiguity in Grammar and Languages from the third unit of Theory of Computation. Objectives are to understand the concepts of ambiguity in context-free grammar and to analyze the grammar to check for ambiguity. First of all, let us see about the derivations and types. Derivations means deriving a string from the given grammar, that is substituting the non-terminals with the help of the production rules to produce a string. This process is called as derivation. The derivation can be of two types, leftmost derivation and rightmost derivation. If at each step in a derivation a production is applied to the leftmost variable, then the derivation is said to be leftmost derivation, and a derivation in which the rightmost variable is replaced at each step is said to be rightmost derivation. Now we can see the example for leftmost and rightmost derivation, and we will be given with the grammar and we will be given with the string. So we have to perform the derivation for the given string in both ways, in both leftmost and rightmost derivation methods. And we can see how to perform a leftmost derivation. So in any cases we have to start with the starting non-terminal s tends to bb. So we have to, if the non-terminal starting symbol having more than one production, we have to choose the production which is appropriate to our string. That is, our string is starting with small letter b. So the appropriate production is s tends to bb. So similarly, in every cases we have to choose the productions based upon the input symbols available in the string. And the important thing is, in the second step we can see our derivation step will be bb, capital letter bb. So in this point we have to, in the next step we have to apply the substitution for the leftmost non-terminal. So in the leftmost derivation, in each steps we have to replace the leftmost non-terminal and we have to perform the necessary substitutions. And finally we will try to produce the string. And in the rightmost derivation, in each step we will resolve the rightmost non-terminal. We will perform the substitutions for the rightmost non-terminal variables. So this is the case happening in the rightmost derivation. And we can construct the derivation tree for either leftmost and rightmost derivation processes. Now we are going to see what is meant by ambiguity in grammar. So if a grammar is said to be ambiguous if there exists more than one leftmost derivation or more than one rightmost derivation or more than one parse tree, then the grammar is said to be ambiguous grammar. So if the grammar is able to produce a unique parse tree for a given string, for a given derivation, that particular grammar is called as unambiguous. So unambiguous, the grammar should not be ambiguous. The ambiguity in grammar leads to many problems in the compiler construction processes. So when we have to identify the ambiguity in a grammar and we have to eliminate the ambiguity by doing some of the processes. So if we identify a particular grammar is ambiguous, we have to rearrange the grammar by introducing new non-terminals so as to make it into unambiguous. So let us see the example. We are having the grammar with production rules. So first of all, we have to analyze whether the given grammar is ambiguous grammar. So we can take on example string w equal to id plus id plus id, and we have to do both leftmost derivation and the rightmost derivation, and we have to construct the parse trees for the corresponding derivations. In the leftmost derivation we can do like this: e tends to e plus e. Based upon our string id plus id star id. So in the leftmost derivation we can take the production e tends to e plus c. Then we have to do the substitutions from the leftmost variable. So id plus e. So we have to do in this manner, and this is the corresponding parse tree, and this is the rightmost derivation. So from the two derivations, there are two parse trees can be constructed for a given grammar. So two parse trees having two different structures. Two parse trees corresponding to two type of derivations leads to two type of structures, two different structures. So this leads to ambiguity. Such kind of grammar is called as ambiguous grammar. Now we have to remove the ambiguity from the grammar. So the ambiguous grammar can be made as unambiguous by introducing several variables for enforcing the precedence. Now we have to take what are all the from our grammar we have to take what are all the operators available in the grammar. So now we are going to see one problem. In this problem, we will remove the ambiguity for the given grammar. So in this problem also we will choose one string and we will perform the leftmost and rightmost derivation, and we will identify the ambiguity in grammar. Then we will do the process of removing the ambiguity. For that, first of all, we have to take the operator precedence. We have to analyze the operator precedence. So in the given grammar, we are having the operators plus, star, minus, bracket. All the special characters, the bracket will be considered as one of the operator, that is which is used to enclose some operation. So the bracket will also be considered as the operator. So according to the operator precedence, the operators have to be arranged. The priority order of the operators have to be arranged. Then based upon the priority order, we have to rearrange the grammar, and we have to use the new grammars, new non-terminal variables. For example, so initially the least precedence have to given for addition and subtraction. The least precedence have to given for addition and subtraction. So we can use e tends to e plus t. T is the new non-terminal we are using here, and e tends to e minus t. Then we have to connect the next non-terminal to the previous non-terminal, like e tends to t. Now the second important operator is multiplication. So we have to add the productions in the second step. T tends to t star f. Here f is the new non-terminal. Now we have to connect the previous non-terminal to the next non-terminal, like t tends to f. Now f tends to, finally in the right hand side we have to apply the least precedence operator. So the least precedence operators are bracket. So we have to put bracket e, capital letter E, or, and finally we have to apply our terminal symbol. Our terminal symbol is A. So f tends to A. And the important thing is we have to connect all the intermediate non-terminals to the starting non-terminal, and the last non-terminal will be connected to terminal in this manner, like e tends to the first non-terminal, starting non-terminal is capital letter E. Capital letter E tends to capital letter T. T tends to F. F tends to A. This is the sequence of order. This is the order in which we have to relate the non-terminals, and finally we have to relate the final non-terminal into the terminal symbol. So the important thing is we have to choose the operators, and we have to arrange the operators in a precedence based upon the priority, and we have to apply the rules in the precedence order. So in this way we can rearrange the grammar, and when we try to derive a string with the help of this new grammar, we will get the unique parse tree for the given grammar. So now we made our grammar into unambiguous. So in this slide we can see the derivation for the given string with the new production rules or the modified production rules and the corresponding parse tree. So that's all about the topic. And the possible university questions are: explain ambiguity in grammar with example, check whether the given grammar is ambiguous, and make the grammar unambiguous. Thank you.